There's a moment in every great endeavor when success stops being theoretical and becomes operational. When a machine or a system, after years of refinement and testing in one location, is replicated and deployed in a new environment. This moment separates the proof of concept from the infrastructure of civilization. SpaceX is approaching such a moment. After Flight 14 successfully demonstrates orbital operations from Texas, after the company proves that Starship can launch, reach orbit, deploy cargo, and recover both stages on the same mission, there is one more transformation that must occur. The rocket must leave Texas. It must journey to Florida, and on a launch pad at Kennedy Space Center, on the shore of the Atlantic Ocean. In the shadow of the same facilities that sent Apollo astronauts to the moon, SpaceX plans to launch Starship into orbit for the first time from a location other than Boca Chica. Flight 15 is not just another test. It represents the expansion of operational spaceflight from a single facility to a dual-facility infrastructure. It is the moment when Starship stops being an experimental rocket at a development site and becomes a true operational system. To understand the significance of this transition, you must understand what launching a rocket from Florida actually means. Kennedy Space Center, on Florida's Space Coast, has been humanity's gateway to space for 60 years. It is where Saturn V rockets carried Apollo astronauts to the moon. It is where the Space Shuttle launched hundreds of times. It is where Delta, Atlas, and Falcon rockets continue to lift payloads to orbit. But Kennedy Space Center is not a blank slate. It is a complex, intricate environment where every system, every facility, every inch of infrastructure has been engineered to support specific launch vehicles. The pads were built for specific rockets. The launch tower designs are tailored to specific spacecraft, the ground support equipment, the fuel lines, the electrical systems. The data network solve-it has been built around the vehicles it supports. Introducing Starship to Kennedy Space Center means adapting an entirely different launch environment for a rocket that is fundamentally different from anything that is launched from Florida before. Starship is taller than the Saturn V was, more massive than any operational rocket today, more powerful than anything in the Space Shuttle era. Its structural design is unique, its propellant systems are different, its launch sequencing is different. The ground infrastructure that worked for Space Shuttle will not work for Starship. New systems must be built. SpaceX has been preparing for this transition for years. The company has been studying Kennedy Space Center, designing launch facilities, coordinating with NASA and the Space Force, which shares operational control of Kennedy. They have been planning how to integrate Starship operations into an environment where multiple entities operate simultaneously, where Falcon 9 rockets launch, where Artemis missions are prepared, where international partners conduct operations. Adding a Starship launch pad to this complex, crowded environment requires extraordinary coordination and engineering innovation. The first Starship facility at Kennedy will not be a duplicate of what exists at Starbase in Texas. It will be an adaptation, designed with the lessons learned from operating Starship in South Texas, but configured for the unique constraints and opportunities of Kennedy Space Center. The launch pad itself must be hardened against the salt spray of the Atlantic Ocean, against the humidity of Florida's subtropical climate, against the hurricane winds that occasionally threaten the Space Coast. The ground systems must integrate with the existing Kennedy infrastructure while maintaining the flexibility that SpaceX has built into its operations at Starbase. The decision to launch Starship from Florida is not merely about geographic convenience. It is strategic. Kennedy Space Center is closer to many potential orbital inclinations that are valuable for satellite deployment. It provides access to equatorial orbits for certain missions that would be difficult to achieve from Texas. It allows SpaceX to manage a higher launch cadence by distributing flights across to facilities rather than concentrating everything at one location. And critically, it demonstrates that Starship is not tied to a single facility, that it can integrate into existing space infrastructure, that it can adapt to different environments. This is essential for the company's long-term vision of making spaceflight routine and affordable. Flight 15 itself will be historic not because of what it will do in space by that point. Starship will have already achieved orbital operations on Flight 14, but because of where it will launch from. Gwynne Shotwell, SpaceX's president and chief operating officer, has indicated that if all goes well, Starship could launch from Florida, before the end of 2026. This timeline is aggressive, but achievable. Flight 14 is targeted for late summer or early fall. The data from that flight will inform preparations for Flight 15. If the readiness timeline accelerates, as SpaceX hopes, Florida launch operations could begin while 2026 is still young. The ground teams preparing Kennedy's Space Center for Starship represent the intersection of two eras of spaceflight. There are engineers who worked on Saturn V who have seen multiple generations of rockets, who carry decades of institutional knowledge about what it takes to launch humans to space. Alongside them are young engineers from SpaceX who have grown up with rapid iteration, with the understanding that rockets should be reusable, that launch costs should decrease, that spaceflight should become routine. This combination of historical knowledge and innovative thinking is essential for successfully introducing Starship to Florida's space infrastructure. The launch pad infrastructure at Kennedy is unlike anything SpaceX has built at Starbase. Kennedy's pads have been hardened through decades of operational experience. The electrical systems are redundant and robust. The water systems designed to cool rockets during launch and suppress the sound of the rocket engines are sophisticated engineering systems themselves. The launch tower that must support Starship is not a simple structure. It must withstand the thrust of 33 Raptor engines, the vibrations of launch, the structural loads of a 400-foot-tall vehicle carrying thousands of tons of propellant. And critically, it must incorporate the mechazilla. Catch arms the mechanical hands that will attempt to grab Starship during landing in a way that integrates with Kennedy's existing facilities. One of the most remarkable aspects of the Florida expansion is how SpaceX has learned to build and adapt launch infrastructure at unprecedented speed. At Starbase in Texas, the company built a second launch pad in a matter of months. They constructed ground support facilities in parallel with vehicle development. They invented new approaches to rapid refueling, vehicle inspection, and pad turnaround. These capabilities, these skills, these lessons learned will transfer to Florida, but they will also encounter new constraints. Kennedy Space Center has decades of established procedures, safety protocols, and environmental commitments. SpaceX's approach to rapid iteration, while powerful, must be adapted to this environment. The environmental considerations alone are substantial. Kennedy Space Center is surrounded by sensitive ecosystems. The Indian River Lagoon, one of Florida's most biodiverse areas, is adjacent to launch facilities. Atlantic sea turtles nest on nearby beaches. Manatees inhabit the waterways. Every major launch requires environmental assessments to ensure that noise, vibrations, debris, or other effects will not harm protected species. Adding Starship launches to Kennedy's operational environment means extending these assessments. Understanding how the most powerful rocket ever to launch from Florida will interact with one of the country's most protected ecosystems. SpaceX and NASA have worked together to design launch procedures that minimize environmental impact while enabling ambitious spaceflight operations. The regulatory framework for Flight 15 is complex. The FAA maintains licensing authority over all commercial spaceflights. NASA and the Space Force have jurisdictions over Kennedy Space Center. The state of Florida has environmental review authority. All of these entities must coordinate to permit Starship operations at Kennedy. This is not as simple as approving a single mission. It involves approving ongoing operations, establishing standards for environmental compliance, determining ranges for trajectory modifications if needed, establishing protocols for crew safety and facility security. The process has been underway for months. And if schedules hold, the necessary approvals should be in place before Flight 15 is ready. What is perhaps most fascinating is how Flight 15 will represent the maturation of Starship from a development program to an operational system. Flight 14 proves that Starship can accomplish the technical objectives. Flight 15 proves that Starship can operate in diverse environments, that it can launch from different facilities, that it can integrate into existing space infrastructure. This is the transition from revolutionary to evolutionary, from innovation to operation. It is the moment when the rocket stops being something SpaceX is developing and starts being something SpaceX operates repeatedly, with regularity, as part of the nation's spaceflight capabilities. The international implications of Starship operating from Florida are also significant. Kennedy Space Center is one of the most iconic space facilities in the world. When Starship launches from there, it signals to the international community that the United States is committed to maintaining its position as a spacefaring leader. It demonstrates that American innovation and American engineering can adapt ancient facilities to serve new purposes. It shows that the commercial space industry is not a fringe activity, but an integral part of national space infrastructure. The logistics of actually moving Starship to Florida are themselves remarkable. The vehicles must be transported from Boca Chica to Kennedy Space Center, a distance of about 320 miles. SpaceX has been developing procedures for vehicle transport, special vehicles to carry Starship and Super Heavy through public roads, coordination with local authorities to permit the movement. This is not a simple task. Starship stands over 400 feet tall when stacked with its booster. Moving such a vehicle through populated areas requires extraordinary engineering and coordination. The personnel requirements for supporting Starship operations at Kennedy are also substantial. SpaceX will need launch directors, test engineers, ground support technicians, safety officers, and dozens of other specialists on the Florida team. Many of these will be transferred from Texas operations. Others will be hired locally. This represents an investment in Florida's space economy, jobs for engineers and technicians, and expansion of the region's technological infrastructure. Kennedy Space Center, which has seen workforce fluctuations over the decades, is experiencing renewed growth as commercial spaceflight expands. The relationship between SpaceX and NASA at Kennedy Space Center deserves attention. For decades, this facility was almost exclusively the domain of NASA and government contractors. The arrival of commercial space companies has transformed this. SpaceX operates some pads. United Launch Alliance operates others. Blue Origin is planning operations. Kennedy Space Center has transitioned from a purely government facility to a multi-tenant spaceport where commercial companies operate alongside government missions. Flight 15 launching from Kennedy represents the full integration of SpaceX operations into this new model of spaceport management. The economic implications of Starship operations from Florida are substantial. Each launch requires enormous amounts of logistics, supplies, equipment, and personnel. The local economy benefits from the employment, from the supply chains that support rocket launches, from the tourism that surrounds major space missions. As SpaceX increases launch cadence, as it moves toward monthly or more frequent launches, the economic impact on Florida's Space Coast will grow substantially. One of the interesting challenges that Flight 15 will help address is the question of launch direction and trajectory. Texas and Florida have different geographic positions. They offer different inclinations and orbital trajectories. A mission launched from Texas toward the Gulf of Mexico must follow one trajectory. A mission launched from Florida over the Atlantic Ocean follows a different path. This provides SpaceX with flexibility in how it schedules missions and what orbits different launches can achieve. Some satellites prefer certain orbital inclinations that are more easily achieved from one location than another. Having two facilities allows SpaceX to optimize launch scheduling based on customer requirements and orbital mechanics. The question of how quickly Flight 15 could follow Flight 14 is also interesting. SpaceX has talked about monthly launch cadences. Theory with two facilities, it could achieve even higher cadences by distributing launches across facilities. But this requires extraordinary operational efficiency, perfect vehicle reliability, and ground systems that can turn around and relaunch vehicles in weeks rather than months. Flight 14 and Flight 15 will provide data about whether this goal is achievable or whether more time is needed between launches. The role of human spaceflight in Flight 15's timeline is worth considering. NASA needs Starship to be certified for crewed missions to support Artemis lunar landings. Before astronauts can fly on Starship, the rocket must prove its reliability. The vehicle must demonstrate that it can operate safely from multiple facilities, that ground systems can reliably process it, that recovery systems work reliably. Flight 15 contributes to building this operational history. Each successful flight from Florida adds to the database of evidence showing that Starship can operate safely and reliably. The international space industry is watching these developments with intense interest. Russia, China, and Europe are all developing heavy-lift rockets, but none have yet achieved the full reusability that Starship is demonstrating. The successful expansion of Starship operations to a second facility would represent a